Hello friends, good morning. Today we will solve exercise 2.4. Okay, this is lecture number 9. This is lecture number 9. Okay, now the first question of the exercise 2.4 is that determine which of the following polynomials has x plus 1 a factor. Which was that? Determine which of the following polynomials has x plus 1 a factor. Okay, the first part is x cube plus x square plus x plus 1. Second part is x power 4 plus x cube plus x square plus x plus 1, and third part is x power 4 plus 3x cube plus 3x square plus x plus 1, and the fourth part is here x cube minus x square minus 2 plus root 2 x plus root 2. Okay, in this question we have determined that x plus 1 is a factor of the given polynomials or not. Clear? So first of all, we know that if we compare this with 0, then we get the zeros of the polynomials, and if we put this value, means a, in this polynomial and it becomes 0, then according to Vendor theorem, we apply the factor theorem after that, and we prove that this is the factor or not. फर्स्ट ऑफ ऑल हम क्या करेंगे, x प्लस 1 को 0 से इक्वेट करेंगे, इसकी वैल्यू फाइंड आउट करेंगे, इस वैल्यू को इस पॉलिनोमियल में पुट करेंगे, अब p a जो आता है 0 है, अकॉर्डिंग टू फैक्टर थ्योरम इट इज द फैक्टर ऑफ द गिवन पॉलिनोमियल्स. फर्स्ट ऑफ सॉल्यूशन. First, we compare according to Vendor theorem equal to 0, x plus 1 equal to 0, x equal to minus 1. Now, we put x equal to minus 1 in this polynomial, and if the value of the polynomial is 0 at this value, then it is confirmed that x plus 1 is the factor of this polynomial. So p minus 1 equal to minus 1 cube plus minus 1 square plus minus 1 plus 1. Okay, so p minus 1 equal to minus 1 cube means minus 1, minus 1 square means plus 1, and plus into minus plus. Here we said 1 cancels out, means p minus 1 equal to 0, means at this value x equal to minus 1, the value of polynomial is 0, hence it is the factor of this polynomial. Okay, hence x plus 1 polynomial. Okay. Now this is the next one. We apply the same process for this. First of all, we equate this with 0. X plus 1 equal to 0. X equal to minus 1. Now we put minus in place of x, and if the value of p minus 1 is 0, then it is confirmed that it is the factor of the given polynomial. If the value of p minus 1 is not 0, then x plus 1 is not factor of this polynomial. Now check. P minus 1 equal to minus 1 power 4 plus minus 1 power 3 plus minus 1 power 2 plus into minus 1 plus 1. Okay. Now we see that P minus 1 equal to, as we know that if the power is even of a negative number, then sign will be positive. Here the sign will be positive, and when it is multiplied 4 times itself, then the value will be 1. And if the power of a negative number is odd, then the sign will be negative. Hence, minus 1 power 3 minus 1 plus into minus is minus 1. Here the power is even, hence the sign will be positive. 1 minus 1 plus 1. Which that this is cancelled out. P minus 1 equal to 1 means p minus 1 is not equal to 0. Hence x plus 1 is not a factor. Hence x plus 1 is not a factor of the polynomial. Okay. Now we discuss the next part. The third part is that x power 4 plus x cube plus x square plus x plus 1, x is factor of this or not. Again we compare x plus 1 equal to 0, x equal to minus 1. Now we put in this polynomial minus 1 power 4 plus 3 into minus 1 power 3 plus 3 into minus 1 square plus minus 1 plus 1. P minus 1. Okay. Now see that. Minus 1 power 4 1 plus 3 into minus 1 cube minus 1 into 3 minus 3 plus minus minus plus minus 1 square 1 3 into 1 3 1 is 3 plus into minus here minus plus 1. We see that 1 cancel out, minus 3 plus 3 cancel out. Again p minus 1 equal to 1. Here p minus 1 is not equal to 0. Hence x plus 1 is not a factor of polynomial. Okay. Now we see the fourth part of polynomial. The fourth part of the polynomial is x cube minus x square minus 2 root 2 plus minus 2 plus root 2 into x plus root 2. We see that here x equal to minus 1 we put p minus 1 equal to here minus 1 cube minus 1 square minus 2 plus root 2 into minus 1 plus root 2. Now we see that p minus 1 equal to minus 1 cube minus 1 square plus 1 into minus 1 minus into minus plus 2 plus root 2 plus root 2. Okay, we see that minus 1 minus 2 plus 2 root 2 plus root 2 to root 2. Okay, we see that cancel out. Here p minus 1 equal to 2 root 2. So p minus 1 not equal to 0. Here it is not equal to 0, hence x plus 1 is not factor of polynomial. Okay? In this way, all parts of question first is completed. Now, we will discuss the second question. Use the factor theorem to determine whether g is factor of px in each of the following. Okay? The question is that use the factor theorem to determine whether g is factor of px in each of the following cases. As in previous lecture, we discussed the integral root theorem, rational root theorem, and factor theorem. You have to use the factor theorem to check that if the given polynomial is the factor of the another polynomial or not. Now we see that the first part of the question second. The first part of the question second is that px equal to 2x cube plus x square minus 2x minus 1. Gx equal to x plus 1. Means we have to check that x plus 1 is a factor of the given polynomial or not. By using factor theorem, first of all, we equate gx to 0 and find value of x. After that, we replace the value of x in this. We put the value of x in this polynomial. If the value of this polynomial becomes 0, then according to factor theorem, x plus 1 will be the factor of this polynomial. Here x plus 1 equal to 0, x equal to minus 1. Now we put p minus 1, 2 into minus 1 power 3 plus minus 1 power 2 minus 2 into minus 1 minus 1. Now we see that minus 1 cube minus 1, minus 1 into 2 means minus 2, minus 1 square 1, here 1. Minus 2 into minus 1 means minus 2 plus, here 2 1 are 2 and minus 1. We see that the minus 2 minus 1 is minus 3, 1 plus 2 3. Means this value is 0. P minus 1 is 0. S means PA equal to 0. If PA equal to 0, then x plus a will be the factor of the given polynomial. Hence x plus 1 is factor of p's. Okay, फर्स्ट हम क्या करेंगे, gx को कंपेयर करेंगे 0 से, वैल्यू ऑफ x फाइंड आउट करेंगे. आफ्टर द वैल्यू ऑफ x को हम पुट करेंगे गिवन पॉलिनोमियल में. इफ वैल्यू ऑफ पॉलिनोमियल कम्स टू 0, देन अकॉर्डिंग टू फैक्टर थ्योरम it confirms that the given gx is the factor of the px. Okay, we see the second part. The second part of this question is that px equal to x cube plus 3x square plus 3x plus 1. Gx equal to x plus 2. We follow the same procedure as in previous questions. First of all, we get x plus 2 equal to 0. Now, we find that x equal to minus 2. Now we replace x by minus 2. So p minus 2 equal to minus 2 cube plus 3 into minus 2 square plus 3 into minus 2 plus 1. Minus 2 cube, 2 to the 4 to the 8 minus 8 plus 2 to the 4, 4 to the 12, 3 to the 6 plus into minus minus plus here. We see that the value is minus and minus 6 minus 14, 12 plus 1 13 equal to minus 2. Means p minus 2 equal to minus 1. Okay, now the value is minus 1 means is not 0. The value is not 0, hence p a not equal to 0. Hence x plus 2 is not factor of px. Okay, according to factor theorem, pa is 0, then factor, but here p minus equal to minus 1 means pa is not equal to 0. Hence x plus 2 is not factor of px. Okay, now the third part you will try by yourself. Now we see the question number 3. The question number 3 is that find the value of k if x minus 1 is a factor of px in each of the following. Question number 3. First part, px equal to x square plus x plus k. Is given that x minus 1 is a factor of px. It is given that x minus 1 is a factor of px. If x minus 1 is a factor of px and we put x equal to a in this polynomial, then pa will be equal to 0, a cardinal factor. Now we see that here means when x minus 1, when this polynomial is divided by this polynomial, then the remainder will be equal to 0. Now first of all, we equate it with 0, x was equal to 0, x equal to 1. Now we put 1 in place of x in this polynomial. p1 equal to 1 square plus 1 plus k equal to 0. Because x minus 1 is factor of this polynomial, hence the remainder will be 0. Now 1 square plus 1 plus k equal to 0, k plus 2 equal to 0, k equal to minus 2. Clear? If the value of k is 2, then x minus 1 is the factor of this polynomial. Now, we see the second part of this question. The second part of this question is that px equal to 2x square plus kx plus root 2. Px equal to 2x square plus kx plus root 2. Okay? And x minus 1 is factor. Okay? Now, see that. First of all, we equate x minus 1 to 0, x equal to 1. Now, we put x equal to 1 in this polynomial and equate it with 0. t1 equal to 0. If x minus 1 is factor, then px should be equal to 0 means p1 will be equal to 0. Now we put here 2 into 1 square plus k into 1 plus root 2 equal to 0. 1 square 1, 2 1 are 2. 2 plus k plus root 2 equal to 0. Or k plus 2 root 2 equal to 0 or k equal to minus 2 plus root 2. This is the value of k. Now, the remaining two parts of this question you will try by yourself and we will discuss the next question in next video. Thank you.